Hello, everyone, and welcome to the risk management training for project managers. My name is Greg Davis, and Rob Quigley and I will be presenting this training. I'm going to start the training off with a quote. The pessimist sees the difficulty in every opportunity, and the optimist sees opportunity in every difficulty. This quote is from Winston Churchill, and as a project manager, you have to wear both of these hats. All right, today's training will include introduction to risk management. We will also go through the risk management process and also provide some additional information that you need to know about risk management. Okay, so what is risk? Project Management Institute defines risk as an uncertain event or condition that, if it occurs, has a positive or negative effect on the project's objectives. And these objectives are mainly scope, schedule, and cost, and primarily the effects are negative. However, risks are defined as threats, which are the negative effects, and also opportunities, which are the positive effects. During the risk assessment, the goal is to identify the probability of occurrence and the cost and schedule impact of each risk. And these risks relate to the project scope, events, and budget. Risk management's aim is to identify opportunities and mitigation strategies to reduce both the impact to the cost and schedule of a risk and also the probability of occurrence. Project management risk objectives is to increase the probability and impact of positive events and decrease the probability and impact of negative events on the project. This will help in making better decisions by the project manager. Also, it will allow allocation of these risks to the individuals that can best control them. It will increase the agency credibility by providing reliable costs and schedules, and also foster good relationships with project stakeholders by including them in the risk management process. Okay, so let's look at a typical project scenario without risk analysis. Here you see the plan, cost, and schedule graph for a project. But what happens, the risk on these projects, if they're left unmanaged, will increase both the cost and schedule and result in a project that's late and over budget. Okay, by including risk analysis in the process, the cost and schedule will stay closer to the planned activities because the risks that are identified early in the process will be mitigated as a project develops. And then this results in a project within budget and on time. Okay, so what are the outcomes of risk management? Validation of project cost and schedule, managed risk response plan, which includes the high cost and schedule risk drivers, a managed contingency box with excess funds from risk mitigation going back into the program for additional projects, and also a better understanding and being able to communicate cash flow requirements and financial plans. Risk management builds confidence and credibility in the project's estimates, promotes proactive practices and early planning, facilitates development of response strategies for all threats and opportunities, better allocation of risk to those who can better manage those risks, facilitates traceability of risk throughout the life cycle of the project, and also identification of the best project delivery method, whether it's design build or design bid build. The big picture is that with risk management, you have a better management of program contingencies, opportunities to reallocate funds that are made available through risk mitigation, and also enables cash flow financial management. So next, we will go through the risk management process. So I'm going to turn it over to Rob Quigley.
Thank you, Greg. So a project is like a journey, and it has a beginning and an end. And along the way, you're bound to encounter things you weren't expecting. So we want to manage risk as we go through that journey. The first step in cost risk analysis and management is to start planning for this journey and organizing the information that you're going to need along the way. This will help you address any obstacles that you find. So what is needed to get started? Here's where you want to start gathering the data and organize it for consistency and completeness. You'll need things like project information, total project cost and schedule, and with the cost, we're looking at the base costs of the construction costs and any other support costs like PD&E, design, utilities, right away, things like that. And also the schedule, the Primavera schedule, or if you don't have that yet, just a high-level flow diagram. You also want to start bringing in personnel that are involved in the project. You'll be the project manager, but you also need to involve your estimators, schedulers, your consultant designers, and any other subject matter experts that will be involved in the project. Now, you may not know as much at the early stages of the project, but that's a good time to get people involved. Okay, the next step of cost risk analysis is to identify or predict the obstacles you might encounter along the course of the project. So where do you start? You can start with a list of potential risks that you may encounter. There are some pre-established risk startup lists. You can use lessons learned or previous project history or knowledge to come up with potential risks, and also team brainstorming. And we get much of this information from past experiences and project knowledge from those that have been involved in the project or similar projects. During this process, you may end up with a large number of potential risks, and even some that may be very unlikely. And that's okay, because that helps you document that you did consider any of the risks that are possible. The analysis will help you focus on those risks which will have the biggest potential impact. You also develop clear risk statements and identify what you know about each of the risks, like which phases affected the cause, and document why it's a risk. Is it a risk to the cost or the schedule, or both? Is it a threat or the opportunity? And one thing to remember when looking at cost and schedule risks is that you're looking at the base cost and the base schedule. Those don't include any fluff or contingencies, only the actual estimated cost and schedule. Through the analysis, you'll be able to determine a risk-based contingency. All right, the next step is to assess the risks. As mentioned earlier, this is where you estimate the probability or the uncertainty of occurrence and the potential impact of each risk. This involves refining the risk statement and determining the affected components and activities, triggers and indications, related risks, again, the likelihood of occurring and the impact, as well as the resultant cost and schedule risks. So for each risk, you'll need to determine the most likely probability of occurrence, impact to schedule, impact to cost. This is a best guess at this point, and depending on the analysis you'll be using, you may also need to come up with the maximum, minimum, and most likely values for those. So for the risk depicted here, we've estimated that it will have a 40% probability of occurring, and if it does happen, it will impact the schedule by 60 days, and it will impact the cost by $100,000. Okay, so now that we've assessed the probability and impact of each risk, it's time to conduct the analysis. The type of project you have will dictate the type of analysis needed, and it will either be a qualitative or quantitative analysis. We'll discuss this a little bit more in the presentation, but basically a qualitative analysis is a more basic analysis, and it ranks the order of the risks, or the highest impact to the lowest impact risks. When you do a quantitative analysis, you start to bring in the actual cost and schedule impacts, and it's a deterministic or probabilistic analysis. We're going to focus mainly on the quantitative analysis since it's more involved. Okay, once you've determined all of your risk factors and assigned potential cost and time impacts, you can model the risks through project quantitative analysis. This is a probabilistic model run through a Monte Carlo simulation. What it does is it looks at all the risk factors and all their values and their ranges, and it runs through sometimes 1,000 or more iterations to come up with some binned results. It takes these results, and the output from the model after it's run is a cost curve. There's other outputs as well, and we'll talk about that in a second. But right here, we show the cost curve for construction costs. This shows a range of potential costs and probability as related to the base cost. The cost we're looking for is the 70th percentile cost, which in this case is $41.7 million, whereas the base cost is 30. Please note that this is the pre-mitigated analysis, meaning if we were to proceed with construction without any further risk management, we would expect to spend almost $12 million in overruns. The model also outputs a similar curve for the schedule. And in this case, again, the estimated construction completion was originally February of 2015, and based on the 70th percentile, it would be more likely to be August 2015. Another output is what we call a tornado diagram, and it does this for cost and schedule risk factors, but this one is the cost risk factor. And what the tornado diagram does is it basically ranks the risks, the top, in this case, top 10 risks. You may have 20 or 30 or 40 risks on the project, but after going through the analysis, these are the top 10. These are the ones that you really need to focus on. And the final output of modeling is the risk register. It's not necessarily an output, it's more of a tool that's put together for managing the risks. And what this does is it contains a list of all the risks and all the information about each one, from the costs, the impact, schedule, values, those that are assigned to the risk, things like that. And it's a place to manage all that. So the next step in the process is response strategies and developing those. And this is where we explore the different things that we can do to address the risks. So identifying risk response strategies involves planning, and a risk response plan is a plan of action designed to reduce the impact once a risk event has occurred. So it involves planning prior to the risk event occurring as though it will occur. So you assume it's going to occur. Identifying what the trigger is, or the point in time that you'll know that the risk will have happened or did not happen. And the implementation of your response strategy, so that if the risk does occur, what are you going to do to address it? And there's 4 different methods of risk response. Actually, there's 4 for threats and there's 4 for opportunities. For threats, you can either avoid the risk, mitigate it, transfer it, or accept it. And if it's an opportunity, you can exploit the opportunity, enhance it, share it, or accept it as well. And we're going to talk about these one at a time. On avoiding or exploiting, avoidance is a strategy where for threat, you would change the project scope to eliminate the impact. So essentially, you cut out that part of the project where that risk may be occurring. If you're going to exploit, you make a proactive decision to take action to show that an opportunity is realized. The next response strategies are transfer or share. If it's a threat, you're going to transfer the risk, which means you move it to another party who's more capable of handling the risk, such as the contractor or an insurance company. If it's an opportunity, you want to share, which means assigning ownership of the opportunity to a third party who's best capable to capture the benefit of the project. Another response is mitigation or mitigate for threats or enhance for opportunities. To mitigate a threat, the project team may seek to lessen the impact of a specific risk item, which may involve the consumption of additional time or money, and it does require positive action, and it usually has a cost. To enhance an opportunity, you take action to increase the probability and or impact of the opportunity for the benefit of the project. You'll seek to facilitate or strengthen the cause of the opportunity and proactively target and reinforce its trigger conditions. In this case, we're again looking at that risk. In this case, it was a threat. Probability of occurring 40%. The impact of the schedule was 60 days, and the impact of the cost was $100,000. Now, if you take mitigation as your strategy, you may have to do something, and it may cost, $10,000 of additional work that you do ahead of time or in preparation of the risk event happening. But in this case, we've reduced the probability of occurring to 10%. Still have a 60-day impact to the schedule if it happens, and it still has a $100,000 impact if it happens. So we've, in this case, just reduced the probability. To accept is to take no action when a response may be too costly to be effective, or when the risks are uncontrollable and no practical action may be taken to specifically address it. When you do active acceptance, the project team sets up a contingency reserve fund to account for the residual expected value of the remaining risks. And finally, hope is not a strategy. You can't assume that nothing is going to happen on the project and hope for the best. You can hope for the best, but you can't expect the best always. Okay, please note that with any of these response strategies, you'll need to reassess each risk and determine what the new probability and impact will be, and then you'll rerun the model. Once you rerun the model, you'll get some more output curves. In this case, we're again looking at the construction cost, and what you expect to see from a mitigated risk model is the curve actually moves to the left, and that's the goal, is to move it further to the left. So where the original amount, the 70th percentile cost was going to be $41 million, we've pushed that through risk mitigation down by $2 million. It's a minor change, but it shows that the risk mitigation strategies have helped reduce the impact and cost. Same thing with the schedule. In this case, the schedule showed a more significant impact from risk mitigation, and the 70th percentile moved from August 2015 to May 2015. It also shows you the effects on your tornado diagram of those same top 10 risks and where they stand after the mitigation has been taken into account. All right, so the next step is monitoring and controlling your risks. Now that you've taken into account response strategies and mitigation, you don't just put down your register and start working. You need to also, throughout the life of the project, monitor for risk events that may occur and manage them as they occur. So tracking, monitoring, control, again, it involves your risk response plan, your risk management plan. You'll continue to identify the risk owners, your monitoring frequency, how often are you going to look at it? How often are you going to get feedback from others that are involved? You may need to update the risk model as things occur, or once risks are realized or it's determined that they are not going to happen because you've passed the trigger point. So you'll continue to manage the risks, you'll update your risk management plan, and you'll rerun the model as necessary. Throughout the process, you'll be managing your risks using the risk register. And again, it's the heart of this process, and that's a good one-stop location to get a snapshot of all the risks on the project. And you can incorporate it with your progress reports. Again, in risk response tracking and monitoring and control, you can document in your risk register things that happen along the way. In this case, we're looking at a risk, and the strategy that was determined to be used was mitigation. The action that was going to be taken was to finalize design to identify all wetlands that are impacted, early coordination with the outside agencies to determine mitigation ratio. They've assigned the risk to the design leader and environmental manager, and they've reviewed the risks on December 2nd, 2008 and January 2nd, 2008. The status as of November 15th, 2008, there were only 2 potential areas where there could be additional wetland impacts. And then another note, as of December 2nd, 2008, agency has initially determined that the mitigation ratio would be 4-1. So the risk register can be a place where you document some of these decisions. And essentially that's the risk management process. And I'm going to turn it back over to Greg for some additional risk information.
So you may be wondering, why do we need risk analysis? Well, in traditional cost estimating, what we've done is develop a cost for all of the planned activities for a project and throw in a blanket contingency to cover the unknown. This provides little control over the cost of schedule because we don't know the basis of the blanket contingency, and push into a reactive mode because you can only react when the risks occur. With risk-based estimating, these risks are clearly identified and quantified up front so that you will be able to have reasonable control over the cost and schedule, which makes it a more proactive approach. Why do we need risk management? to help stabilize and support the work program with better cost estimates and schedule, validate the cost of schedule that's used for project delivery, and also to replace that general blanket contingency with a risk-based contingency that could be managed. We enhance project management activities by including risk assessment and mitigation in your project meetings, and also support FHWA requirements for financial plans on major projects by supporting the financial plans with a risk-based cost estimate. And in general, it just maximizes the likelihood of meeting time and budget goals on your project. All right, so contingency management. Here we have a project with the base cost of $456 million. The escalated base cost is $550 million. And then there to the right, you can see an S-curve that shows the risk-based estimates through various confidence levels. Typically, projects are programmed at the 70% confidence level, which shows a estimate of $670 million, which results in a 22% contingency. So the idea here is to develop risk mitigation strategies to reduce that percentage to as low as you can, and the additional funding that's available from those mitigation efforts can be recycled back into our work program to fund additional projects. The risk register is also, and this was mentioned earlier, should be included in your project management meetings to discuss mitigation efforts that you've done on the project. And then for FHWA major projects, we have the project delivery timetable, which I'll talk about in just a minute. But FHWA also requires that programming for the major projects are at the 70% confidence level. FHWA requires that the 2 cost estimate reviews are done, one just prior to NEPA, and one before the project is authorized. Here's the FHWA timetable. This was for design, build, and P3s, and there's a similar one for design, bid, build projects. As you can see here, we have the cost estimate review activities, which I talked about earlier. There's a cost estimate review that's required within 90 days of NEPA approval, and also a cost estimate review that's required between 90 days and 1 year before the submittal of the initial finance plan, which will go to authorize the project. So the financial plan has to be submitted to FHWA before the project is authorized, and has to receive approval from the Office of Innovative Programs Delivery Project Team. And these financial plans are updated on an annual basis as the project progresses through construction. Our project management plan is required 60 days prior to approval of a NEPA decision. And the division also would look for updates when there are major changes in the project scope. Project selection guidelines for risk analysis. Complex projects are any project with a total project cost of $500 million must be led by a consultant, independent consultant, through a risk analysis workshop. Most of these projects are federal highway major projects, but there are some turnpike projects that may meet this threshold, but does not have any federal funding. Any total project cost greater than 100 million, but less than 500 million, also requires a risk analysis workshop using a commercial risk modeling tool, but a consultant led workshop is optional. some of these workshops can be led by in-house staff. Projects not requiring a formal workshop, and typically these projects are less than $100 million total project cost. The project manager and the district estimator can use the risk analysis self-modeling tool on the CRA SharePoint site, which I'll give a reference to a little bit later. In this case, the project manager and the district estimator can work together to load this self-modeling tool with the pertinent risk and run the model to get the same information as you would from the workshops. And the last is the qualitative risk analysis risk-based graded worksheet. This approach is used to early on to determine the risky areas of a project, and this normally aids in the consultant selection of the consultant that's best to manage the project. So in our risk workshops consist of a 2 to 3 day structured event. During this workshop, we identify and quantify risks, threats, and opportunities on the project. We'll also identify various strategies that can be used to manage those risks. And it's all one big collaborative effort with the project team and the subject matter experts. Folks that participate in these workshops, of course, we have the project manager and their design team. We have various subject matter experts. In addition to the ones that you see there on the right, we also may have experts that cover areas such as geometric design, or maybe a certain construction process that's going to be used on the project. We also have internal and external stakeholders that may be participating in the project. Okay, objectives of a risk workshop. Identify project risks to account for uncertainty in scope, cost, and schedule. Assess the project risk by quantifying impacts to cost and schedule. That is, the likelihood that the risk will occur, and if it does occur, the impact it will have on either cost or schedule. Analyze the project risk through modeling to develop a baseline risk assessment. Produce a risk register for future monitoring of identified risk. And then review cost and schedule for all of these different areas that you see here: right-of-way, environmental, PD&E, just to name a few of them. Okay, here's some references that you can use that give information about risk management. We have the Chapter 19 of the Project Management Handbook. We also have a SharePoint site with various documents on cost risk analysis. And then the FHWA has a major projects website. Okay, so this concludes the training, and we'll open it up for questions. And if you have any questions following today's training, you feel free to contact one of the members of the risk management team that you see below.